This is the second section of chapter 1, and in this section we're going to be looking at unbalanced problems and degenerate solutions. So first of all, what is an unbalanced problem? So an unbalanced problem is one where the supply and demand are not equal. In the examples we've done before, the supply and the demand have been equal. So what do we do if they're unequal? Well, if the supply is greater than demand, we have excess capacity. So that means the suppliers are producing lots of stuff, but there's no demand for it. We could have, on the other hand, where supply is less than demand and we have unmet demand. So during the pandemic, for example, people were buying lots of toilet rolls and pasta. So there was not enough supply to meet that demand. And in both of these unbalanced cases, we add a dummy to balance out the demand and supply. So in the case where our supply is greater than the demand, what we will do is add another dummy demand point to absorb this excess supply. So in this first case here, we would add a dummy demand point. So dummy demand. So that will be like another column that we would need to add, and that will absorb this extra supply that we have and create this dummy demand point for it. And if we have the opposite case where the supply is less than the demand, or the demand is greater than the supply, we need to add another supply point to absorb this extra demand. So we would add another row in our table, and that will be a demand dummy supply. So the demand is also like the depot or the destination, all begin with D. So secondly, let's look at what are degenerate solutions. So a problem is degenerate if the supply equals the demand when we're doing the northwest corner algorithm before we complete the northwest corner algorithm. So before you get to the end, you've used up all the demand or supply of a certain point, and it matches exactly the demand of a certain point. And if that happens, then we've got a degenerate solution, which means we can't continue any further. Now, let's imagine that we're doing the northwest corner algorithm on a matrix, a grid of values, which is m columns and n rows in size. We can tell if a problem is going to be degenerate because the number of cells used in the northwest corner algorithm will be less than n plus m minus 1. So for example, if this was 4 by 3 here, 4 by 3, so you've got 4 destinations, 3 supply points, then 4 plus 3, 7 minus 1, 6. So if we use less than 6 cells when we're doing the northwest corner algorithm, it's going to be a degenerate solution. Now we can correct this and avoid this problem by adding appropriate zeros into our grid, and I'll show you what we do and the alternatives for adding zeros when we get to those examples. Example 3. 3 outlets A, B and C are supplied by 3 suppliers X, Y and Z. The table shows the costs in pounds of transporting each unit, the number of units required at each outlet and the number of units available at each supplier. So here we go. Here's our grid. So remember that these values in here, the ones I'm highlighting in yellow, they are the costs, whereas the numbers at the sides here that I'm going to highlight in orange, these are how much demand each of the suppliers A, B and C wants. So A needs 50, B needs 40 and so on. And X, Y and Z, and these numbers at the side represent how much the suppliers are able to supply. So there's our supply and here's our demand here. So part A is asking, explain why it is necessary to add a dummy demand point in order to solve this problem. So dummies are added when we have an unbalanced problem. So let's show that it's unbalanced. So let's look at what the demand is. So that's going to be 50 plus 40 plus 30. So all I'm doing is adding together these three numbers here. So the demand is 120, and not part B, but now I'm going to be looking at the supply, how much is able to be supplied. So the total of the supply is those, so 40 plus 60 plus 50. So we have a supply of 150. So we have an unbalanced problem. The supply is greater than the demand. So we have excess supply or excess capacity. So since this problem is unbalanced and we need to add demand to absorb the excess capacity, that explains why we need to add a dummy demand point. I probably not put this sentence very well, but the reason why we need to add a dummy demand point is that the problem is unbalanced and we need to add the extra demand point to absorb the excess capacity. So this sentence really isn't great. I should have started by putting this at the beginning of my sentence. Part B says add a dummy demand point and appropriate costs to the table. So we already have demand points A, B and C. Unfortunately for us, next letter in the alphabet, D for dummy. So we'll complete the rest of this table. So I've almost completed the table. I've just got this column to put in. So to absorb this excess capacity, I'll put 30 here. So now this adds up to 150 and this adds up to 150, which is what we want. The demand and the supply are equal. Now this dummy is just to absorb this extra supply that we have, but it's not really anything. It's not like a company, it's not an organization, it's just there so that we can carry out our algorithm. So there are no costs involved. They're not really buying anything, they're not selling anything, it's just there so that this becomes now a balanced table matrix so that we can carry out the algorithm. And part C, use the northwest corner method to obtain an initial solution. So here's my table ready to do the northwest corner method. So remember, we don't use the costs, we only have in the demand and supply, and we include our dummy in the algorithm. Okay, so let's go through this now. So depot A needs 50. Now they can get 40 from supplier A, so we'll put 40 in there. So that uses up all the supply from that supplier, and then that means that they need 10 more to satisfy their demand. So they'll use 10 from supplier Y. So now depot A is happy, or outlet A is happy. They've got everything they need. Supplier X is happy because they've used up all of their supply. So now we go on to outlet B. Outlet B needs 40. Now they can use up 40 of supplier Y. So we'll put 40 here. That leaves 20. Let's see, 10. That leaves 10 left for the next one. So we can tick off outlet B. They're happy, they've got everything they need. We've used up 10 and 40. So we have 10 left to allocate to C. So we'll put 10 there. So supplier Y is happy, they've all been used up. And then C, they need 20 more, don't they? Because they need 30 in total. So they can use 20 from supplier Z. So we'll tick that off. They're now happy. And then we move on to the dummy. So remember, the dummy's here just so that we can complete the algorithm. So supplier Z has 30 left. Remember, we've got excess supply in this case. So we'll just put 30 there. That means that supplier Z is happy and our dummy is happy. It's all been used up. We're able to get right to the end and all our values have been used up. There's nothing left over. Example 4. The table shows the cost in pounds of transporting each unit to 3 retailers A, B and C from 3 suppliers W, X and Y. It also shows the number of units required by each supplier and the number available at each outlet. Part A, what we need to do is use the northwest corner method to obtain an initial solution. Well, the first thing we need to do is to check whether the problem is balanced or not. And you should always do that if this bottom corner here, the totals of the supply and demand are left empty. That could mean that the problem is unbalanced. So we need to check that. So first of all, we'll work out the amount of supply available available, which is going to be 55 plus 70 plus 65, and that gives us a supply of 190. Then we'll check the demand, and the demand is 74 plus 72 plus 68, and that adds up to 214. So that tells me that my problem is unbalanced. And before I carry out the northwest corner method, I need to add a dummy to make it balanced. So what I've got here is that my supply is less than the demand. So we need to add a dummy supply point. Now, if you're not sure which one to add, dummy supply or dummy demand, you're always going to add the dummy to the lowest value to make up the shortfall or the excess. So that's the smaller one. So that's where we add the dummy. So my little tip here is add the dummy, that'll be the supply or the demand, to the lowest value. The lowest value, or another way you could say is that your inequality sign is going to point towards the one where you need to add the dummy. So my inequality sign is pointing towards the supply. So it's actually telling me add another dummy supply. So we'll get this table ready to carry out the algorithm. So still have the same demand points of A, B and C, and they demand 74, 72, 68. I still have demand or supply points W, X, Y and Z. This is going to be my dummy supply point. I'll put the demand down here, and they can supply 55, 70 and 65. Now I need to work out what the shortfall is. So 219 minus 190 gives me 24. So that means my dummy needs to be able to supply 24 units. So now it becomes a balanced problem. Both the row and columns add up to 214. So now I can do the northwest corner method. So starting in the northwest corner up here, A needs 74. Well, they can't get all 74 from supply W. So they can get 55 from supply W. So supply W is used up, they're happy. They then need to go to the next supplier and get another 19, I believe, from that supplier. So we'll put down they can get 19 from there. So that means that depot A or retailer A is now happy, and supplier W is happy. Okay, so how about B? Retailer B. Retailer B needs 72. Right, there are 51 left from supplier X, so they can use up all 51 from supplier X. So supplier X is happy, B's not happy yet, they need some more. They will need another 21, and they'll need to go to the next supplier, Y, so they'll get 21 there. So now they're happy. So we now move on to the third one, C. Retailer C needs 68. Well, they can use some of supplier Y's, and that will leave 44. So they can use up 44 of theirs. So they're all used up, but supplier or retailer C isn't happy. They haven't got everything they need. We're using up a dummy, remember, so even though we put 24 here and we say okay, they're both happy, we're using up 24 from a dummy supplier, a supplier that doesn't really exist, a supplier that's there just for the purposes of this algorithm so that it balances. So we'll move on to part B, and part B says state with a reason which retailer has not had their demand fully met, and that is retailer C, these 24 non-existent dummy units. So I'll put retailer C has not had their demands met, as they have used 24 dummy units. In other words, C is 24 units short of what they need. So remember, those 24 units are there for the algorithm, not because they actually exist in real life. Example 5. The table shows the unit cost in pounds, so that's all this stuff in the middle here, or transporting goods from supply points W, X, Y, Z to demand points A, B, and C. It also shows the number of units required at each demand point, so that's these values here along the bottom, and the number of units available at each supply point, so those these values here, and we can see that the problem is balanced. The supply is equal to the demand. Part A, demonstrate that the northwest corner method gives a degenerate solution and explain why it is degenerate. So let's fill in our table so that we can do this northwest corner method. Okay, so let's start with demand point A. That needs 30, and supplier W needs 30 or can supply 30. So that gets used up. Now straight away I can tell this is going to be degenerate. When this type of thing happens, before you get to the end, we've used up a supplier and they've exactly met this demand, which means there's nothing left over for supply B or for demand point B. I've got to go straight to the next one. So in other words, I'm not going to be filling anything in this box or anything in this box here. I'm going to be going straight to this box here. And you'll see later that we don't want to do that type of thing. We actually want to sort of move across and down from one box to another rather than going diagonally. So I'll tick these off and we'll see what happens next. Right, so that means now I'm going straight to supplier B or demand point B. I have to go down here. They need 40 units. They can take 20 from X. So they're happy. They need to take another 20 here from the next supplier. So now their demand is met. That means there's 15 left over for the next one. Demand point C, and they need another 35. So I can tick this one off. They've used up all their supply. 35 here. And that means they've had their demand met and suppliers used up all their supply. So since this is a 3x4 table that we have here, so we've got 4 rows, n is 4, 3 columns, m is 3, and using that rule, m plus n minus 1, 4 plus 3 minus 1 is 6. we've only used 1, 2, 3, 4, 5 of those cells. So the problem is degenerate because of this rule here. And later on, as I said, you'll see that when we use something called a stepping stone method, it requires us to be able to move across and down, not diagonally. And part B, adapt your solution to give a non-degenerate initial solution, and we're going to state its cost, which means we're now going to have to refer back to this table and the values that we have here. Right, so this is just a copy of the table we had from part A. To adapt this solution, what we need to be able to do is to step across or down from one box to another. At this point we can't do that. Now I can make that happen by either adding a 0 in this box, okay, so you can see then you go down, across, down, across, down, across, or I can put a 0 into this box. Again, it just allows me to go across and down to get to the bottom corner, as long as I can do that. So it doesn't matter where I place it, I can place it in one of those two boxes, so that I've got that rule that says, right, I'm only allowed to go down and across. Now it doesn't matter which one we place it in, I'm just going to place it here, but either one will be fine. So now I'm going to work out the costs. So this tells me the number of units, and the original table tells me the costs of those units. So I have demand point A and a supply from B. So what I'm going to do is highlight in the cost table which costs I'm looking at. So W and A, B and X, B and Y, C and Y, and C and Z. So I'm going to multiply those costs by the number of units. So these are the unit costs here. So for example, to work out the cost of these 30 units, I'm going to do 30 times 10. So here's the complete calculation. 30 lots of these units that cost 10, 20 lots of these units that cost 5, 20 lots of these 8s, 15 lots of these 7s, and 35 lots of these 9s. It's a full calculation, and it does say that the cost is in pounds, so I need to give my answer in pounds, and this all adds up to £980 as the total cost for this initial solution. So you should now be able to do exercise 1B on pages 10 to 11 of the textbook, and we've got like a little recap here